So now we are going to continue just 15 minutes to finish to explain the potential use of SpaCY, because I think it's worth for all of you. And after these 15 minutes, I give the floor to Javier de la Rosa, that is going to explain, more than explain, is going to talk about a different approach to the study of text or literary text. Maybe it's more complex, but in this part, you only need to relax and enjoy the conversation with Javier, that speak, by the way, speak very nice English. So I know that is better. Okay, so Álvaro, I give you the floor, and in 15-20 minutes I make something like and stop it. Okay.
Okay. Okay, hi again. We're going to continue where we left it. We loaded all our language model into NLP, and we are going to use this to do stuff with our text. It's very simple, using just we can call NLP with a string. It can be a variable or whatever we want, but must be a string. We just run this, save into another variable, okay, sentence, for example. And then we can see the tokens in this sentence variable. You can run it. I'm not going to run again, but this is the result you should get. It's 1 line per token. You can see that the exclamation mark is another token, as I told you before, numbers, punctuation, everything is a token, everything that is not a white space or a new line. But spacing is not just splitting the text. It's also doing more advanced stuff. For example, tagging each of the token with the part of speech tag it has. It works pretty well. It's not perfect. Yes, the complete tag set is here, but it's pretty self-explanatory. For example, we can see the part of a speech of these tokens if we access to the pose property of the token. We need this hyphen. I don't know the name of it. No. Underscore. Yeah. Without the underscore, you just get a number that it's what SpaCY uses internally. If you want to see what this represents, use the underscore. And you can see, for example, I, pronoun, love, verb, pizza is noun, and the exclamation mark is punctuation. Yes, the microphone. If we don't put the underscore, yes, you get a bunch of numbers. Yeah, it's what SpaCY uses to operate internally. You don't usually need this information. It's just for SpaCY. Yeah.
Thank you. I'm sorry, it doesn't work on my computer because we have token and then comma, token and then point, right?
Yes.
POC and underscore.
POS underscore.
Yeah. Sorry, I just can't see it very well. Thank you. It works.
Okay. Okay, more things that we can do with SpaCY is, for example, wait. Okay. The dependency parsing. It's missing an I here. Okay. You can see the grammatical relationship between the tokens in a sentence. For example, we can use this sample sentence, and again use NLP to analyze what happened.
May I ask something while you are fixing it? We have done this tokenization. So I have pronoun, verb, noun, and punctuation. Can we get it in Excel? Because when we have a big amount of data, it's like maybe in Excel or.
Yes, you can save that information in several ways, actually.
No.
Gracias.
¿La pantalla compartida?
No, ahora la pongo.
Pantalla compartida.
Ahora sí.
Okay. Okay.
Sí.
Okay, sorry.
Archivo editar, ver.
¿Dónde? Okay, sorry for the delay. Back to SpaCY. So, wait a second. Okay. I have to rerun some of the code. Okay, so we can also get the grammatical relationship between the tokens in a sentence. For example, if we have this sentence, Apple is looking at buying whatever. We analyze this with our language model, and then we can use SpaCY. It's a tool from SpaCY to visualize information. In this case, the grammatical relations. And you can see, maybe we can see this. No. I'm going to make it smaller. Okay. So this is doing it in real time. We just parse the sentence and use this SpaCY render the document that we are going to render, in this case, this one. And the style is sorry. The style is what kind of visualization are we gonna see? In this case, is that for dependency parsing. Yes, you can see it works pretty nice. Well, this can be useful if you want to get the root of a sentence or whatever information you may need from the grammatical dependency tree. Okay. Another thing very useful we can do is NER. NER is name entity recognition. Is having a text with maybe proper noun, city names, organization, dates, a lot of things that you can name. SpaCY can detect a lot of them. For example, I've used a recent news article. The source is here if you want to go. We saved the news article into a variable and we parse the news article. Oh, sorry. Lower down. Okay. We saved our parsing in the doc variable. And now we can use the same. the same command as before, but instead of dep, we are using ent for the style for entities. And this is all detected by SpaCY. You can see proper nouns, dates, even tomorrow is a date, this week is a date, the last few days is a date, so it's very powerful. Maybe you don't know what some of these labels mean. For example, GPE or FAC. You can list them. There is a command called SpaCY.explain. So you can say, okay, print all the labels for NER and a definition of what is each one. For example, we have cardinal, date, event, buildings like airport, for example, countries, languages, all of these SpaCY can detect pretty accurately. But yes, this is fancy. I mean, it's colorful and all that. But if you're working with, for example, a book of a collection of books, this is not going to be of much help because you're going to have a lot of lines of text. So you have to do another kind of operation. This is very nice for short tests, maybe news article or social media post or something not very long. But if you want to work with books, we are going to use another kind of techniques. We are going to reuse the function for downloading a book, okay? And we are going to use books from the Gutenberg project. We need IDs, like Salva explained. You can get it, for example, if you just want one ID, you can search for a book in Gutenberg project, and the ID is the number in the, maybe I should make this bigger. Yeah, not much better. Okay. So this is the ID. Okay, the number in the URL. Or if you don't want to go one by one and you want to download a set of books, for example, I don't know, maybe by genre, by author, by language, you can query the Gutenberg project website to get this information, okay? For example, I want to get all the books on the Gutenberg project site that with the topic horror, okay? We can use the Gutentext library that we used before. It's pretty straightforward. You just use this command and you'll get something that it's maybe scary. Okay. It's like a huge amount of text. And this is what we are getting from the Gutenberg API response. Okay, it's a lot of information. Don't be scared. It's just a list. Okay, a list of results. It's a dictionary with more information, but we are interested in the results. That it's just a list. Okay, a list. You can see here the bracket because it's a list, and it has the items of the list are a dictionary. Okay, a dictionary containing the information from one book. For example, the first item. Sorry, too much. Okay, sorry. For example, we can see the first result. The ID is 84. It's Frankenstein. A list of author. Maybe this only has one author, but in case it has several authors, they are here. Translators, subjects, this is manually annotated, probably. Horror tales, gothic fiction, in which bookshelf it appears in the Gutenberg project, languages, and a lot of information that for now is not useful for us. Okay. So this list of results, it's sorted by popularity, by number of downloads. It's more or less popularity of the book. Okay. So we're going to get the top 5 most downloaded books in the Gutenberg project in the category of horror. Okay. It's a list again of just 5 elements. We are going to see right now what are the books. Okay. So this is a list, like I say. So we are going to iterate through it. And for every book in this list, we are going to get the book ID, the book title, the author, and the number of downloads, just to see how popular it is. And this is a very short list. We have Frankenstein, the second is Dracula, the third one is the Metamorphosis, fourth, Jekyll and Mr. Hyde, and fifth is Carmilla. Yeah, I didn't know this book, but it's the 5th most popular book. And we can get, now we can use our function. Instead of typing each of these 5 IDs manually, we can go through this list and get the ID and save each one of these IDs to download our books, okay? It's working, you're not seeing anything, but it has already downloaded the books, okay? And we are going to create a data frame. Don't be scared of data frames. We are going to use it just as a table, okay? We can create a data frame directly from this list of books. And it automatically knows, because how it is formatted, what are the columns, are the rows. And see, this is just to see it. We are not going to do anything complicated with it. The title, the author, downloads, and the full text that we are not going to show is just the beginning. Okay? Okay, what can we do with this text now that we have it? For example, we are going to start with Frankenstein. We are going to analyze the text. So we are going to call our data frame, that is called corpus df, the column text, and the first element. So this exact cell, okay, the text of the book. We parse it with SpaCY. It may take less than a minute, I think. And this is everything in the book. This is all the text, but since we are going to work just with the words, we can filter most of the useless information. With SpaCY, this is very, very easy. We are going to iterate through our text. Again, this is tokenized with SpaCY. So for each token in Frankenstein, we are going to add to a new list of filtered words anything that is not punctuation, that is not a stop. This means out of vocabulary. I mean, words that SpaCY doesn't know. New line characters, anything that white spaces, and we must ensure that we are adding something that is alphabetical. I mean, it has characters in it, okay? And we append all the words. This is words, basically. We append this word to a new list. So now we have a very clean version of Frankenstein. For example, we can see an example here. This is a list of words. Just a list. Each of these elements are part of a list, just made of words. Okay, so now we can count how many words does Frankenstein have without punctuation or anything that it's not a word. And it's 30,000 words. Okay. We can also see calculate what are the most frequent words in the text. And we are going to use a dictionary to count. It's very simple, the logic, you'll see. We are going to iterate through our filter Frankenstein, our clean text. And for each token, we are going to normalize the tokens by using the lowercase version of the words. And for each token, we are going to add the token to a dictionary. If the word is not, if the word is in the dictionary, okay, we are going to add one to the value. This is the key of the dictionary is the word, and the value is the number of times it occurs, okay? If the word is already on the dictionary, we are going to add one to the value. If it's not, we are going to set the value to 1. And that's all. Sorry. You can, I think it's, you can follow this on your own. I think this is very well explained. You can follow the code and execute everything. There are explanations for everything. Okay. The final result of the notebook is to try to guess which of the books is the most scary. Okay, so
which ones?
I won't spoil the answer. It's again, I think you can follow this on your own. It's very well explained, and if you have doubts, maybe ask in the chat or tomorrow or whenever you want.
Okay, I have an idea. Homeworks. Yes, you can continue. Yeah, you can continue the notebook, and tomorrow you have to say us which was the more scary text, no, for the computer. Okay.
No, lo puedo hacer más molesto.
For the computer. If you change the parameters, maybe change the opinion. Okay. So the people who is going to work hard and not going to see the football can make this. Okay. Perfect. If you are going to support Real Madrid, it's okay. If you are going to support Manchester City, homeworks.